And I'm going to share the screen. So we will discuss the last application of Stack. And in our course website, the new forum that I set up yesterday, I also ask you guys to work together to find more application on Stack. And that will give you some sense of how Stack is used in some application scenario. And I don't know if you still remember whenever we discuss the memory, we said, oh, we have stack memory and we also have heap memory at that time. So basically, after we learn stack, maybe you can recall and find, oh yeah, over there we did have the word of stack. At that time, maybe we have not too clear idea about what a stack is. But right now, after we learn stack, then when we go back to recall that idea, then you will find it makes more sense. Okay, so here it discuss, we call it a runtime stack. Okay, the runtime stack, and it says whenever a function begins execution, so that means you call the function, is it? And there is an activation record, so regarding that function, and it's going to be created to store the current environment for that function. And normally what activation record has about the function is its parameter, its call state information, some local variables within the function, and some temporary storage within the method. So previously what we learned is we said, oh, we have a stack memory. And we also said we have heap memory. Is it? So this is stack memory, and that is the heap memory. And I'm not sure if you guys still remember the heap memory normally have space for what? For whatever, like whenever you call new, is it? And all of those new stuff will go to the heap memory. But within your stack, you have somewhere to reference that object that you created in heap, is it? But no matter what in stack, and here it says we have the runtime stack, is it? And let's go back to take a look at the next slides to probably better understand. And so, you know, when you have a function, when you have a program, that within the program's entry point is main. So program entry point. Entry point is that main function. It's always start with main, is it? And that's because the operating system will look for it and to start to execute your program, is it? But within main, generally speaking, you have some other functions. You're going to call other functions. Is it? And when you call the function, it will go into that function and execute, is it? And when the function finishes, when a function finishes the execution, so you may wonder, how can it know that it go back to where the main stops, is it? So that's a question. And also in one function, you may call other function. And when you finish the other function's execution, how can it know to go back where it stops to call the other function? So all of this question, so basically what the operating system arrange everything is, it's uses that runtime stack. And the runtime, because it's a stack, so basically it follows what we discussed about stack. It's the LIFO behavior. And then let's take a look. Probably let's take a look like in this scenario, okay? And so here we have a scenario. And in this scenario, we have the main. So basically what the runtime stack going to have, it's going to first to push the main into the stack. So this is at a runtime stack. So it first pushes the main to the stack. And then over here, it call function 2. So function 2 is going to be pushed to the stack. Is it? And we don't have function 1 here. Okay, and then within function 2, it has function 1. Is it? So function 1. So at this point, the program runs to function 2. Is it? So it's going to push function 2 to the stack. And then it's function 2, when the function 2 executed, it's called function 1. So function 1 is going to be executed. So at this point, function 1 is the top within the runtime stack. Is it? So the function 1 is going to be executed statement by statement. Is it? And when it finishes its execution, is it when function 1 finishes execution, so function 1 will be removed from the stack. And then that's why how it knows to go back to function 2. So then the program knows, okay, it will go back to function 2. And the function 2 will continue its execution. And when function 2 finishes its execution, and then it runs into function 3. Is it? So function 3 then will be pushed to the stack. Is it? And then function 3 executed it to run to function 2 again. So function 2 will be pushed to the stack. And function 2, and then function 2 will go ahead call function 1 again. Is it? So it's always the top record, the top one of that runtime of the activation record. The top one is being executed. And after it's executed, and that's why how it knows to go back to the point that it calls that the function. So it resumes the execution of the previous functions. And then when it finishes, it will keep getting off the next top one. So if we take a look, and we can find that the runtime stack, yeah, it perfectly follows the LIFO. Is it? And it keep track of the execution of the functions. And when you finish all of those functions, it get to the main and finish the execution of main. So this is regarding runtime stack. But whenever you have the runtime, whenever you have a function, as I suppose in function 3, and somewhere here you create an object. Okay, suppose it's the time object. So time t then equals new time. Something like that, is it? And then within it, so over here, you have that heap. So that time t is created. So t is still within the runtime stack. So runtime stack, you have the function, then you have the corresponding activation record. So that's the activation record. Okay, but this t, so here is a t, is it? And the t reference the object. So this block is invoked by the new time, is it? And get to the memory. And then that t local variable is stored within the activation record. And the activation record is kept tracked by the runtime stack, okay? So that's the whole picture of what we previously discussed about the stack memory and the heap memory. And hopefully this right now makes sense for you about the stack memory